Hello and welcome to this tutorial about the Blackbox Simulation Airbus A320 for Microsoft Flight Simulator X. We are parked here at Innsbruck Airport inside the cockpit of an Airbus A320. We're going to prepare the airplane now for a flight to Vienna. So this tutorial will cover everything from the cockpit preparation until engine start. The airplane is completely powered down now. It's completely switched off. And we are going to power it up now. The first thing that we should do is to perform the preliminary cockpit preparation, which will make sure that the airplane is in a safe state to power up. For example, we will check that the landing gear lever is down and so on. So we can see there's no power on the airplane right now. Starting the preliminary cockpit preparation takes us first to the engine master switches. We want to make sure that both are switched off and the engine mode selector is in a normal position. Then let's move up to the landing gear lever, check that it's down, and up to the wiper, the windshield wiper switches. You want to make sure they're off so that after we apply power they won't start moving on a dry windshield. Next is the battery check. They're both switched off now, but we can't see the off lights because there is no power to power the off lights. So we want to make sure that both batteries show more than 25.5 volts. Then we can switch battery 1 on. We can see the off light of battery 2 is now powered, and let's switch battery 2 now on as well. After that we can switch on the external power. The away light signifies that an external power unit is connected, and by pressing this button we can actually connect it to the airplane electrical system. Next thing to do would be the APU fire check. Check the APU fire warning, which you would do by pressing the test button and checking all indications and the oral fire warning bell, but it's not simulated in this airplane. Next is to check if the flap lever is in the up position and the flaps actually and slats are also in the up position. Also important is that we have set the parking brake and that we check the accumulator pressure and the alternate braking system, which we will do by just pressing the brake pedals and watching the brake indicator needles go up. If there are icing conditions on the ground, we could switch the probe window heat to on, which would apply low power to the windshield and the probes. But we don't need that right now, so we can just leave that switch in the auto position. Then we do a brief check of the air conditioning and the electrics panel, and also the avionics ventilation panel, if all switches are in the correct position. Next we see if there are any malfunctions from the previous flight. So we push the recall button on the ECAM to see if there's anything popping up, but it doesn't, so that's good. And we'll check the status of the airplane by pushing the status button. Furthermore, we should check the oxygen pressure, which would be indicated here on the real airplane on the door oxygen page, but it's not simulated as well. And we see the status is empty. Okay. Now last thing to check are the circuit breakers. So you turn around and look at the circuit breaker panel, see if there's any circuit breaker popped out, and if yes, what's the reason for it. And that actually concludes the preliminary cockpit preparation. You could now do the outside check and start the normal cockpit preparation. Basically you're moving up the overhead panel. You should basically check that all white lights are switched off. That's the basic philosophy. First of all, you check, you switch on the ground control of the voice recorder, but that's not simulated on the ground. Then you move up, just checking that all white lights are off, like this GPWS system light now. You could switch the evacuation command control just to the captain or to captain and purser. Normally it switches in captain and purser. That depends on the airline. Flight control switches are all on. Now moving up to the IRS, you switch all the inertial reference systems to nav. It's interesting to note here that the sequence of the switches is IR1, 3 and then 2, which could be good to know if you have to apply an abnormal procedure and have to switch on one or more IRS. Now you can see the align lights, and to complete the IRS alignment you have to enter an initial position, which you can do on the FMS via the MCDU. First of all, you have to enter the destination, or I'm sorry, the departure and / the destination airport, so Innsbruck to Vienna. Now you get the align IRS prompt. Pressing this initializes the position. In the real airplane it would take you to another page where you could enter a position, for example the gate position, or use the airport reference point from the database. Now, moving to the lights, switch strobe light to auto, so that if you forget to switch it on after lining up on the runway, it will turn on automatically after liftoff. Navigation lights to 1 during the day, all other lights switched off. Let's say refueling is complete, so we switch on the seatbelt light, seatbelt signs, sorry, and no smoking signs go to auto. They are normally hardwired to on anyway on most aircraft. Let's switch the emergency exit lights to arm, so that we would have a complete power failure, that the emergency exit lights would come on automatically, powered by their own batteries. On the air conditioning panel, we can set the pack flow. If we don't have many passengers, we could put it to low, which would make it more economical. And we can set the temperature selectors for all zones, but as we don't have any APU air, any bleed air right now, we can leave that alone. On the electric panel, we check that all white off lights are extinguished, and we do another battery check. We switch the batteries to off. Then we call up the electric page on the system display. We see that both batteries are switched off now. Then we switch them on again, and we have to check that within 10 seconds both batteries show amperes of less than 60, so less than 60 ampere in 10 seconds, so they are well charged, that's okay. Now we switch on all fuel pumps, so that all off lights are extinguished. And we perform the fire test for the engines, which is not simulated, but you would just push the test button and look if you have all indications. On the ventilation panel, all white lights should be off. Same cargo smoke panel and flight control computers, they are all switched on as well. Now we move down here, check the standby instruments, erect the standby horizon, and set the QNH on the standby altimeter. While we're at it, we can also set the QNH on the glare shield. Let's say it's 1010, and compare it with the airfield elevation. Next we check again that the landing gear lever is down and the NS kit and nose wheel steering switch is in the on position. Also that all the switches on the switching panel are set to norm if there is no operating procedure that tells us anything else. On the audio control panel you should at least switch the interphone volume to on now, so that you can hear if ground crew wants to tell you something. The weather radar is here, it should be switched off now. You can also set the lighting on those two rotary switches of those panels. Check that the speed brake lever is retarded, that the emergency gear extension is stowed, that the transponder is set to auto and the TCAS to standby. Next we move to the ECAM. You could check the status again if you want, and then up to the glare shield. On the way, we can do the FMS preparation. You start at the status page, check that you have correct database, because if after all insertions you notice that the database is out of date, everything will be deleted if you switch databases. Check the correct engine type and the correct performance factor for your airplane. And of course the correct airplane type. Next is the init page A. We've already entered departure and destination airport. Let's say our alternate airport today is Linz, so we put it here in the alternate field. Our call sign today Airbus 123, put it in the flight number field. Then the cost index is basically a measure of how important time versus costs are. So the higher the cost index, the higher the speed will be, but of course the more fuel will burn. That's something that will be calculated by dispatch. Then you enter the cruise flight level. If you don't enter any temperature at the level, then the ISO temperature will be automatically inserted. If you know it, you can also enter the drop or pause altitude of your intended route. Let's conclude init page A. Next is the flight plan page. Now we look at our operational flight plan and enter our planned route. We start with the departure route out of Innsbruck. So we do a lateral revision on Innsbruck, just pressing the line select key left of our departure airport Innsbruck, and then pushing the departure line select key. Let's say we're going to depart on runway 08, and we expect, or we are already cleared the Rattenberg to Juliet, Romeo Tango Tango to Juliet departure. So select it and then you choose insert. Now departure is on the flight plan page. I don't know what the Hotel Alpha waypoint is, so it's deleted. Now from Rattenberg we enter our en route part. Simply click on the prompt at Rattenberg, and you can enter now the route by entering an airway and the point to which you will fly on that airway. So we use Upper Zulu 33 from Rattenberg to Nemal. So let's continue at Nemal, do the same. We'll continue via the airway Upper Lima 725 to the point Gamli, which will enter in the same way. So that was wrong. You have to enter airway / exit point of that airway. Okay, insert that again. Now in Gamli there is an arrival route starting into Vienna. So let's insert now the arrival into Vienna. We can also switch the navigation display to the plan mode so that we can watch what we're entering. So we click on Vienna, choose arrival. Let's say we have a southeasterly wind today, so it will be probably runway 16 ILS approach with the Gamli 5 Whiskey arrival. Now click insert. And you can see the arrival route now as a navigation display. Now let's clear that discontinuity. Now we have the arrival route which ends at Balad. At Balad normally a on-off transition to the final approach would be inserted, but it's not in the database. So I simply entered now direct to the final approach, runway 16. So that concludes the flight plan entry. You can also enter a route from the destination to the alternate airport if you want. Next would be to copy this flight plan into the secondary flight plan and then adapt the secondary flight plan for your needs, which would be normally an engine fail procedure or similar, but it's not simulated in this airplane. Next is the radio navigation page. We have ADF, VOR and ILS frequency here. Now normally you could enter the ADF or the NDB you would like to use via the identifier, Alpha Bravo for example, but that's not supported in the sim again, so we have to use the frequency, which is 313. What you can do, however, is put the VOR in via the identifier, and then it will select correct frequency from the database. It's 113.8. Furthermore, we're entering the localizer Oscar Echo Juliet because the departure route is based on it. Again, you have to use the frequency, 109.7, and the corresponding course, which is 66 initially. Okay, so we've entered everything on our radio nav page. Now we can also select the landing system, but on the glare shield, so that we have a localized indication on the primary flight display. Next, let's move to the init page B, so press init and then next page. Here the CG of zero fuel is entered and the zero fuel weight. You can enter the CG in the sim, so just re-enter the zero fuel weight. Let's say it's 58.2 tons, and we have a block fuel of 6.4 tons. Now you should check that you enter fuel or time for the final reserve, alternate, and the route reserve. That's actually not supported in the sim, but the route reserve, so just enter decimal 3, just an example here. Let's make sure now that the zero fuel mass plus the block fuel minus the taxi fuel equals the takeoff weight. Should also double check that with your estimate takeoff mass or the load sheet if you already have it. You could now also enter the wind data for the entire route, climb and route and descent, but it's also not simulated. Last thing is to enter the takeoff data. Normally you would use your performance calculation program to put those numbers out. Now I'm just using some fake numbers. Let's say V1 is 132, VR is 132 as well, and V2 is 141. You can also enter, you have to enter the flap setting here. Standard flap setting for Innsbruck would be 3. And the stabilizer trim value, which you look up in the table and you're getting from the load sheet. Let's say it's 0.5 units up. You can also enter the flex temperature here, if you're using reduced thrust, and the thrust reduction and acceleration altitude. We don't have any takeoff shift today because we are using full length on runway 08, so you can leave that empty. Transition altitude is 11,000, that's correct, for Innsbruck. And then your performance program would also output the engine out acceleration altitude, which you could enter here. Now that actually concludes the FMS preparation. Next is the glare shield scan. Here on the glare shield you have the interface to the autoflight system. So we switch both flight directors on, we switch the landing system on. If the departure runway has an ILS, or in Innsbruck it's a localizer we can use. Normal setting is to put the constraints on, set the mode to arc and any suitable range, like 10 miles for example, for departure. We switch both needles to the ADF, and on the altitude we set our initially cleared or expected altitude. In Innsbruck normally initial clearance is to flight level 120. So we enter this here. It's a bit tricky with the 100s here in the sim, but I'm trying. Okay, finally, flight level 120 is armed. We can see on the primary flight display, climb and nav are armed, and one flight director 2 shows that both are engaged. Okay, let's fold out the table. Very important gadget in the A320 cockpit. And actually you would be now ready to perform the before start checklist. We check that the cockpit preparation is complete, that gear pins and covers are removed, so they should be in the cockpit right now. Check that the signs, seatbelt signs are on and no smoking signs are auto. That the ADRS is in nav mode. You can check that on the MCDU by using the data button and pressing the position monitor prompt and checking that all IRSs are in nav mode. Next is to check the fuel quantity, if it's above the minimum block fuel according to your flight plan. Also now check that the takeoff data is inserted, which means all speeds and the correct weights. And that the barrel reference is set, so we have set the correct QNH and compared the indicated altitude to airfield elevation. Alright, this concludes now the before start checklist down to the line. We're actually ready for engine start. Time to start the APU, because we will use the APU's bleed air to start the engines. After pressing the master switch, the air inlet flap will open. As soon as it's open, the APU is ready to start. We push the start button and wait until the APU is online. Normally it takes about 1 minute. Meantime, we can watch some of the beautiful scenery at Innsbruck Airport, because it's a quite low APU start today, quite slow. But we have to use the APU for engine start. You could also use an external power source, an external air source, but you would only do that if the APU is inoperative. In the meantime, we can check again the flight plan page if it corresponds to our filed ATC flight plan. And looking back at the APU page, we can see that it's almost there. Now we have 100%, it's available, and APU generator is online. So let's switch the APU bleeder on. Could now also use the temperature regulators to set a nice temperature for cockpit and cabin. Now it's time to switch the external power to a whale so that it can be safely removed by the ground crew. We also see that all our doors are already closed and the slides are armed. So let's ask ATC for startup approval. Now let's say startup is approved. So we switch the beacon light on and we can do the rest of the before start checklist, which is to check that all doors and windows are closed, that the beak is on, the thrust levers are in idle, and the parking brake is set. Now we'll ask the ground crew if the engines are clear to start, and if they agree, we can start them. Engine start sequence on, or the engine start actually on the A320 is very straightforward because of the automatic start feature. So basically you just have to watch. The FADEC will even automatically abort an engine start for various reasons if something goes wrong. So just put the engine mode selector to ignition start first, and then switch the master switch of the respective engine to on. Now on the engine pages you can see N2 rising, the start valve is open, air pressure 34 psi, and igniter beam is active. This grey box behind the N2 value is indicating whether the engine is stabilized, so if that box disappears then the engine is stabilized, which just happened now. Oil pressure is also good, the start valve has closed. So we're ready to start engine number 1. the same is happening now. And 2 rising. Start valve open and igniter B active. Now we get a fuel flow and shortly thereafter light up, which is indicated by a rise in the exhaust gas temperature EGT. Now when the second engine start is finished, then automatically the wheel page is displayed. Now it's time to perform the after start checklist, or first, sorry, the after start items. So you move the engine mode selector back to norm, arm the ground spoilers by just pulling the lever up, setting the rudder trim to 0 by pressing the reset button, moving the flaps to the calculated position, which is configuration 3 today. You can see them moving here. Now in the relay airplane you could just move the side stick a little bit and then automatically on the system display the flight control page will be displayed. It doesn't work in the simulator, so you have to manually open the flight controls page so they can enter the stabilizer trim. You see the stabilizer trim indicated here, and you have to move the trim wheel to set it to the calculated value, which is 0.5 up. Now you also check the status. It's still empty, that's good. You can now also switch off the APU and switch on engine anti-ice and a wing anti-ice if you need it. APU bleed off, APU master switch off. Now it's time for the after start checklist. You check that anti-ice is on or off as required, that you have checked the ECAM status, that the pitch trim is set to the correct value, you read the value here and compare it to the load sheet, and that the rudder trim is 0. Now the after start checklist is complete, and we're ready for taxi. Now this concludes this tutorial. Everything from here on, taxi, departure and so on, will be covered in another tutorial. So I hope you enjoyed this one, and I wish you a very pleasant flight.